Hello friends, welcome to Awdhesh Academy. Today we are going to discuss about the Euclid's division lemma. So the Euclid's lemma states that given two integers a and b, there exist unique integers q and r satisfying this equation a equals bq plus r, where r is less than b and greater than or equal to 0. This is nothing but the normal division we do in our day-to-day life. Here a is the dividend, b is the divisor, q is your quotient and r is your remainder. Now coming to this particular part, this is nothing but suppose we were to divide any given number by 2. So the possible remainders are only 0 and 1. If we divide a number by 3, then the possible remainders are 0, 1 and 2. That is all the numbers which are lesser than the divisor. Let's suppose we divide 5 by 2. So 2 times 2 is 4 and we get 1 as the remainder. So this can be written as 5 equals 2 into 2 plus 1. So here we see that 1 is the remainder. Now suppose we divide 4 by 2. So 2 times 2 is 4 and we get 0 as the remainder. So this 4 can be written as 2 into 2 plus 0. You will see you divide any number by 2, the only possible remainders are 0 and 1. Let's take few problems based on the Euclid's division lemma, which are very important for your exams point of view. So let's take the first problem. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some positive integer. So let's get started with the solution of the problem. So we have by Euclid's division lemma a equals bq plus r. Suppose we take b is equal to 2. So our equation becomes a equals 2q plus r, where r is either 0 or 1. So there are two cases for a, that is a equals 2q plus 0 or simply a equals 2q, and the second case is when a equals 2q plus 1. Now let's take this first case, that is a equals 2q. Now we know that any number multiplied by 2 is an even number. Thus a is equal to 2q is even. Now let's take the second case, that is a is equal to 2q plus 1. Now this cannot be expressed in the form of 2m, so we can conclude that a is equal to 2q plus 1 is odd. Thus we have seen that any positive integer of the form 2q is even and any positive integer of the form 2q plus 1 is odd. Now let's move on to the next problem, which is prove that the product of two consecutive positive integers is divisible by 2. Now let's take the solution. Now let the two consecutive numbers be n minus 1 and n. Thus the product of these two numbers would be n into n minus 1 or n square minus n. So by applying Euclid's division lemma and taking b in the a equals bq plus r as 2, we get n is equal to 2q and n is equal to 2q plus 1. So let's take the two cases. In the first case we have n is equal to 2q. So n square minus n becomes 2q square minus 2q, that is 4q square minus 2q. Now this can be written as 2 into 2q square minus q. Now substituting this part with m, we get 2m. So we have proven that n square minus n is of the form 2m. Thus we can say that n square minus n, or the product of two consecutive numbers, is divisible by 2. Now taking the second case, which is n is equal to 2q plus 1, we see that n square minus n is 2q plus 1 whole square minus 2q plus 1. So here we get 4q square plus 1 plus 4q minus 2q minus 1. Now we can cancel the 1 and we get 2 common, 2q square minus q. Now if we substitute this part for m, we get 2m. So again we have proven that if n is equal to 2q plus 1, we get a number which is divisible by 2. Thus we have proven that the product of two consecutive numbers is always divisible by 2 or is always even. So we have discussed about the Euclid's division lemma and its application through two problems. Now this forms a very important part of your examinations. You may get a question of 2, 3 or 4 marks from this topic. So do it carefully and follow the steps. So thank you for watching the video. Good day.